in our question of the day, you guys said, several people said that the metric system is based on, what did you say? Powers of 10. What does that actually mean? Yeah, so like, give me an example of what that means when you're actually measuring things. Olivia? Okay, well, what about 10s, hundreds, and thousands? What? Zeros? Yeah, but like, what is this? What does it mean if it's based on those numbers, Max?
It means like each unit that's bigger or smaller is like multiplied by.
Yeah, exactly. So based on powers of 10 means that as you build from smaller units to larger units, you go up in increments of 10 each time. And we'll talk about some of those. So that's one of the key things that's important in the metric system, is that it's based in powers of 10. Do you know what is the system that we use more frequently in our daily lives? But you probably don't know your height in centimeters or your weight in kilograms, or probably don't know how far it is from your house to school in kilometers. We use another system of measurement. You know what it's called? Max? Customary or English system or imperial system? Yeah. And what is it based in? Wow. Yes. Basically, it's based in sort of random numbers that have come about through very old means of measurement that don't really make sense. Like, why are there 12 inches in a foot, or why are there 3 feet in a yard? Like, who knows? It goes back hundreds and hundreds of years to when these units were first instituted, before we had sort of a rigid system of measurement. So it's somewhat confusing, right? That it's not easy to convert from feet to inches and vice versa. You know, not as easy as it is in the metric system. So the metric system is based in tens, and we use these prefixes attached to a unit to help us understand what those units mean. So for each thing that you're going to be measuring, there's a base unit. For example, in the metric system, the base unit for length is what? Meter. Right? Meter doesn't have a prefix on it, it's just a meter. What is the base unit of mass? What? A gram. Yeah. So those are the base units, but you can then add to those base units different prefixes that change that unit. So we have, for example, a meter is the base unit of length. A kilometer is 1,000 meters. Okay? A millimeter is 1/1000th of a meter. So here are the prefixes. Now, some are used very frequently, and others are barely used at all. But they all exist in the metric system. So the base unit, if we go higher than the base unit, larger than the base unit, we have deca, hecto, and kilo. Now, there's other units that aren't being shown here. Okay? If we go smaller than the base units, we have deci, centa, millimeter. Okay? So the ones that you really have to know are kilo, the base unit, centi, and milli. Those are the ones we use most frequently. Lots of times the others are not used very often. So kilo means what? 1,000 of the base units. Centi? Yeah, or what if we put that in a fraction? 1/100th? Or milli? 1/1000. Okay. Now, if we can visualize this system of prefixes, we can easily convert from one unit to another by doing what? Multiplying or dividing by 10 or 100 or 1,000, depending on which direction we're going. And even easier is we don't actually have to multiply or divide, because what can you do that's the same thing? Moving the decimal place. So we convert from unit to unit by simply moving the decimal place. So if I have, let me do this on the board. If I have 1 kilometer, how many meters is that? So how do I move a decimal if there isn't one? I add 1, and I'm going to move, so to go from kilometers to meters, how many places do I move it? 3. So I go 1, 2, 3, and I put the decimal there, and what do I fill in? Zeros, and I get 1,000 meters. So if I look at this chart to go from kilometers to the base unit, I go 1, 2, 3 units over, okay? It's 3 apart. So I move the decimal place 3 to the right. What if I'm going from centi to the base unit? 2 to the left. Milli to centi? 1 to the left. Centi to milli? 1 to the right. Base unit to centi? 2 to the right. Kilo to milli? 6 to the right. Centi to kilo? 5 to the left. So you understand we move the decimal place. That's what allows us to convert from one unit to another. Why don't we? Good question. So, do other countries use the metric system? Most of the world does. And we will, well, I guess let's do this. How many meters in a kilometer? 1,000. How many centimeters in a meter? 100. How many millimeters in a meter? 1,000. All right. So, grams. Grams are the units of mass. They're the base unit in the international system. That's another word for the metric system, SI system. So, how many grams in a kilogram? How many milligrams in a gram? 1,000 million is 1,000. So there's 1,000 milligrams in a gram. How many milligrams in a kilogram? 1,000 times 1,000, 40 million. 6 over.
I was close.
All right, so let's try some conversion. 1,000 milligrams is how many grams? Easy, right? We moved it. Where is the decimal place here? At the end. Milli to grams, we move which way? Left, how many? 3. So I put the decimal from here. 1, 2, 3. That's 1 gram. Milli to grams. 1,000. Move the decimal place over to the right 3. All right, well, let's see some numbers other than even numbers. 1,000. 160 centimeters. So let's hold on. 160 centimeters. Where's the decimal? Which way do I move it? Right. How many? 1. What do I get? 1,600. 1,600. All right, I want you to go ahead and finish these. you used to like try to visualize that chart and figure out how many points to move it and in which direction. Yep. Whole slide. And often it helps to actually put the decimal in and like draw little arrows moving it so you get used to it. Oh, did you? All right, 14 kilometers. Now, it also helps just like to think about this. Like, how far is 14 kilometers? Like, it's pretty far, right? The Boilermaker is a 15K, 15-kilometer road race. So how many meters of it? Is it going to be a lot of meters or a few meters? A lot. Which direction are we moving our decimal? Right. How many places for kilo to the base unit? 3 to the right, giving us 14,000 meters. $109 grams. How many kilograms? So raise your hand if you can tell me which direction we're moving in Olympia. How many places? 3. So grams to kilograms goes 3 to the left. Giving us a what, Olympia? 0.109. $250 meters. Meters to kilometers. Wyatt, which direction are we going? How many places? So give us an answer of? Yes, 0.25 kilometers. No, you could add a 0 there. It could be 0.250. It could be 0.25000. It could be 0.25000. Okay. Either one is fine. So the next section is asking to compare two numbers. So to compare two numbers, what do you have to do? You have to make them into the same unit and then compare them. It doesn't really matter which one you convert, but you have to make them into the same unit. So 56 centimeters, okay, versus 6 meters. I guess what you want to put centimeters into meters? Centimeters to meters, what do? To the left twice, and what do you get? 0.56 meters, which is bigger. 6 meters, much bigger. 7 grams or 698 milligrams. 7 grams is how many milligrams? 7,000. 1,500 milligrams versus 1.5 grams. So milligrams to grams, how many do we move it? How many? Which way? 1, 2, 3. They're equal. 536 centimeters. So centimeters to meters, how many? To the equal. All right. Hold on. So all of the countries in gray have the metric system as their recognized system of measurement. If you've ever been to another country, most likely when you go there, you'll see the speed limits are posted in kilometers per hour. You'll see gas that's sold by the liter. You buy milk by the liter. Most countries use the metric system, but not all. So, what countries? So you tell me what country is this? The U.S. What country is this?
India.
Okay, formerly known as, anyone know that? Myanmar. What country is this?
Alaska.
The country of Alaska?
Russia.
That's the United States. In this country?
Japan. Liberia.
Geography wizards. So every other country, their system of measurement is the metric system. Why hasn't the U.S. switched? I don't know. There are sometimes problems. When you look at the English system that we use, much of it doesn't make much sense. For example, here are some units of length. A digit. That's an actual unit of length in the English system. It's 3/4 of an inch. Have you ever heard of furlongs?
No.
Sometimes used in like horse racing. It's defined as originally the distance a plow team could be driven without rest. A league is originally comes from an hour's walk, about 3 miles. So these things came from sort of traditional units that have now become embedded in the English system. Here are some really strange ones. So the units of volume in the English system, there's jigger, which is 2 mouthfuls. There's a jack, which is 2 jiggers. A jill is 2 jacks. A cup, 2 jills. 1, 2 cups. Quart, 2 pints. A pottle, have you ever heard that one?
No.
2 quarts. A gallon, 2 pottles. A peck is 2 gallons. Penny, 2 pecks. A bushel, 2 pennies. A cask is 2 bushels. A barrel, 2 casks. A hogshead. A hogshead is 2 barrels. So, is it important to know about the metric system? Yes. So, in science, whether scientists are doing their research in the United States or in Europe or Asia or Africa, science always uses the metric system. And there have been instances in which that wasn't the case, and therefore measurements and things have to be converted from one to the other. And if that doesn't happen properly, it can lead to serious problems. And here are some things that are mentioned in this video that will help illustrate. All right, so let's move on a little bit to measuring length. So we're going to sort of go through measuring length, then measuring volume, and mass, and finally density. Okay? So length and area sort of go together. So when we measure an object, a rectangular prism object like this, we can measure its length, width, and height. Okay? The length we will call sort of the longest side, and the width and the height or the tallness of the object. If we're looking at a circle, we can measure its diameter, which is the length through the middle of the circle, or the radius, which compares to the diameter in what way? How does the radius compare to the diameter? Half. The radius is from the midpoint to one of the edges. So in the metric system, we have common units, our millimeter, centimeter, meter, kilometer. A millimeter. What do we use for an abbreviation? Mm, lowercase m, lowercase m. How big is a millimeter? Really small. about, if you think about a pencil, a normal pencil, it's about like the tip of the pencil. It's about 1 millimeter. You know, on a meter stick, on a ruler, on the metric side, it's the smallest lines. Those are millimeters. How about centimeter? cm. Imagining your pencil again. Maybe about the width of your pencil or so. It's a little bit less than half a meter. A meter. Just pound, that's the base unit. How big is a meter? Yeah, it's a little larger than, what would you call this? It's not a yardstick. This is a meter stick. You can see it has 10, 20, 30, 40, 50, 60, 70, 80, 90, 100 centimeters. If you look on the English side, a meter would stop where my finger is. So this, a yard would go to my finger. This is a meter. It's a little bit longer. But it's close to a yard. And a kilometer, abbreviation, km. It's a little more than half a mile. So typically, if we're measuring objects, we'll use millimeters if it's a very small object. Once it's more than 10 millimeters, we'll start to use centimeters. After that, until it's 100 centimeters, then we'll switch to meters. And typically, once we get to 1,000 meters, then we switch to kilometers. So we use different measurements depending on how large the object is. When we want to measure something using a ruler, a couple things. We first have to make sure, now on many rulers, the edge of the ruler is not 0. Often it's going to be indented a little bit. What's the purpose of that? If on this ruler, the edge is 0, why could that be a problem? Mitchell? Yeah, if I've been using this meter stick for a long time, the edge might wear down, and then it would give me inaccurate readings. So sometimes there's a little gap there. So we line up whatever object we're measuring with the 0 point. Here's an example. There's a little gap before the 0 point on this ruler. We count how many centimeters. 1, 2, that's not quite 3. And then we see how many millimeters. In this case, it goes to the 9 millimeter mark. Okay, so this is 2.9 centimeters. What's up? Going along with length, we also will use length to calculate the area of a two-dimensional shape. How do you calculate the area of a rectangle? Length times width. How about a circle? Pi. What's pi?
3.1415.
We can use 3.14.
No.
Pi times the radius squared. What does squared mean? Don't say double. Don't say double. Times itself, which is not double usually.
Oh, I don't have
it. All right. So, oftentimes in this unit, listen carefully because this is a common mistake. You'll be asked to calculate the area of a shape, or maybe density. And you'll often see it'll say, show your work. Doesn't mean you need to show your multiplication, but it means you have to follow these steps. When we're using a formula to solve a problem, we first write the formula, like area equals length times width. Then we substitute in our measurements. Area equals 5 centimeters times 20 centimeters. Then we calculate the answer, and we write the answer, including the units, always. Every number needs units. So, here's an example. Area equals length times width. I've written the formula. Substitute in my number. Doesn't matter. Area equals 6 centimeters times 2 centimeters. Yeah. Finally, I need my answer. What's the answer? No. No. No.
Square.
Correct. What the heck? What is why are we squaring centimeters? Because it's area. What we do to numbers, we also do to units. 6 times 2 is 12. Centimeters times centimeters is centimeters squared. We would have to convert to a like unit, and then we would get either centimeters squared or millimeters squared. No homework. Homework canceled. No.